In a fast-paced tech environment, the potential attack surface increases with each release and new app created. Detectify automates cutting-edge knowledge from trusted ethical hackers into the development pipeline for reliable application security. Go beyond the OWASP Top 10. Check your web apps for over 2,000 known vulnerabilities actively exploited in the wild, monitor subdomains for potential takeovers, and remediate security issues in staging and production. Learn more with a free trial at securityweekly.com/detectify. Go hack yourself. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies. Protecting over 7,500 applications and 150 billion production requests per week, Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences patented technology protects any application against any attack with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at securityweekly.com/Signal Sciences. By connecting to your code repository, Accurix generates a topology across your full stack to reveal risks so that you can harden your architecture. It also scans code for violations against compliance and security standards to enforce best practices. In addition, Accurix develops threat models using vulnerability feeds, IAM privileges, and other data to predict potential breach paths. Learn how easy it is to get started with Accurix at securityweekly.com/Accurix.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. Join Ahmed Barakat, co-founder and CEO of Perimeter 81, and our very own Paul Asadorian for a technical deep dive into the problems inherent in legacy VPN technology. Together, they will explore solutions for the modern workforce and how momentum toward perimeterless architecture is helping redefine the future of cybersecurity. Register now by visiting securityweekly.com/perimeter81. In our upcoming webcasts and technical trainings, you will learn how to thwart attackers using deception and how to build a risk-based vulnerability management program. Visit securityweekly.com/webcast to see what we have coming up, or visit securityweekly.com/on-demand to view our previously recorded webcasts. Oh, and we have such a roundup of the usual suspects with wonderful names this week. It's a week of well-named side channel attacks. And I think we'll jump in right into one about Intel and SGX that caught your eye, John. You want to start us off with that?
We'll start off with one of them. How about that? So Platypus, our first named contestant for today, for those keeping track here. So this is a fun one. And Intel was trying to do the right thing here. And one of the things you've got a modern CPU of any company is the ability to monitor what's going on, right? Is the CPU running hot? All these sort of different things, particularly around power usage and CPU temperatures and things like that. Especially for those of us with laptops, when those things are on our lap, that can be sort of important. Or a NUC when it's NUCs will overheat if you run them too fast. In this particular case, someone figured out that you're able to do statistical analysis on the data coming off that monitoring. And this can happen in user space. Modern kernels expose this data so a user space application can present your little pretty graphs. But also you can take the data behind that pretty little graph and be able to extract data out of your XGX enclave. As usual, this is something we call bad.
Especially
bad.
Because AWS just did some really interesting stuff with these enclaves, didn't they?
Both them and I think all three right now are doing it right. So we'll talk about it. Intel is actually quoting the security of the Azure data centers. Google's doing it. Google's using AMD's chip, but Amazon and Azure are both using this, yes.
Yeah.
And to the point too, the researchers also said that AMD ARM exposed these same features. They just didn't have the resources and the time to look into it. So it's not that your chip choice makes a difference here. It's more this capability. Two things that stood out to me. One, very specifically, not to gloss over the fact, is that this type of attack, especially on Linux, which you were describing, that's when you can get that unprivileged access into this kernel module to see this information this type of side channel can be conducted remotely. So this doesn't need local access to monitor or to measure, where some other types of side channel, especially if we're talking about voltage or power consumption and doing that type of profiling, typically does. So that's a pretty cool aspect here. But I also wanted to, and we can continue to talk about the details, but wanted to step back at a higher level. And one of the reasons this is interesting to talk about is not just because SGX Enclave, they demonstrated they could step through instruction by instruction, profile it, figure out how to recover a RSA private key or an AES key from the enclave within a matter of, I think, minutes or actually hours. But this type of measuring is a common side channel, whether you're talking about, in this case, power, or talk about GPS location, or even timing measurements. And we've even seen things as browser capabilities. The Web Application Working Group has gone through a whole bunch of different proposed capabilities to put into browsers that say, we want to have high-resolution timers, or we want to have high-resolution capabilities for mouse movement, or other types of features within the browser. And there's been a lot of, I think, good pushback and good concern from a security and privacy perspective, is that anytime you introduce these types of capabilities to more specifically measure something, there is a lot of potential for abuse. And in this case, we're seeing a very direct consequence with this with SGS Enclave. But the spirit here, it does actually translate to a lot of different domains. So it's not just a worry of hardware and power consumption.
Yeah, it's like I said, it's with my engineer hat on, I always want the most data I can get, either from how's my application performing, who's trying to attack it, we're always looking for data. But as you make yourself more transparent, even just internally, you're taking a risk. So one of the things I did on Friday when I looked at this was, it sounded when they said user space kernel, okay, well, can I disable that in the kernel? So I grabbed a copy of the Linux kernel, and here's some homework for our kernel source, and here's some homework for our listeners. It looks like this is by default, at least on Ubuntu, compiled in as a module. So you might want to think, okay, what are my Linux commands to be able to unload a module, or make sure that module doesn't get loaded, or can you go through and recompile your kernel, favorite activity of all of us, and see if you can actually pull out that module and not allow it to be in there in the first place, and then what's the ramifications of that?
Absolutely. And I think one of the other things is that in the paper they said they responsibly disclosed the findings to Intel November 16th, 2019. So this was almost a year, in fact, in the making to get to this point where we get to talk about it on ASW. So quite a complex vuln. But I think the other comment I want to make on here too is that if you're suddenly starting to threat model the Platypus attack, and you've skipped over the basics of what does your cloud configuration look like, and have you given root privileges to the processes running in your container, you might have missed some of the importance or the smart ways of going out threat modeling. So one final comment there.
Totally.
We will say, so let's turn from Platypus, which is an acronym, which I just scrolled off, so I can't say what the acronym is, but we are going to switch to another side channel in DNS. And here is something that is also kind of interesting, because some researchers basically revived an old protocol attack against DNS, which is basically a way to guess the source port for UDP packets, which of course are stateless, unauthenticated communication channels, datagrams. And they're demonstrating how to use some interesting insights into the way fragments are put back together, and the way ICMP can be combined as an oracle to leak information about ports that can then be used as knowledge service attacks against DNS. And I think here, the thing that stood out to me is SAD DNS is a really, I think it's an easier one to explain perhaps than some of the math behind or the approaches of the Platypus attack. But the protocols are also pretty easy to describe. So they're great sort of threat modeling exercises, if you will, in terms of talking through with developers to get them into a security-minded type of thinking. So I wanted to throw this out there as sort of an educational way of just building security awareness and dragging developers out of code for a moment and thinking in terms of systems or protocols, because that's at the end of the day also what they're building.
What I think is interesting is the fixes here are not that difficult. Like DNSSEC, anyone? Oh, outgoing ICMP would fix aspects of this as well to block that. But again, you look at the fixes and you're like, yeah, we should have done that. So I mean, these attacks can be thwarted in certain ways, but because we haven't adopted some of these secure ways of communicating, we are now susceptible to these types of attacks.
It's funny real quick. It's funny you mentioned that, Matt, because we had a commenter on one of our previous sessions. I think it might have even been last week, talking about BCP 38. So most of our audience probably doesn't know the BCPs. It's the best practices for how an ISP should be running their network and actually sharing back with the rest of the world. And BCP 38 in particular is don't allow your customer base to spoof IP addresses, which isn't part of your network, which you should be broadcasting. This is such a basic thing, which so many people are always constantly wondering, we've been wondering for years, why do not people filter this egress traffic? It's super simple to fix. You don't even have to go towards DNSSEC. But alas, here we are once again.
Alas, here we are. And even in the saddns.net, their website, in their FAQ, they point out, to support your point, John, is that 30% of ASs don't block packets with a spoofed IP address. And this is in 2019. So already, if we just got if we blocked that traffic, a lot of attacks, not only in the SAD-DNS category, but many of the others we've seen over the last couple of years, would actually be strongly mitigated right there.
Yeah, this is super basic. This is, I mean, if I'm to really break this down so that the in case it's not clear enough already for folks, if I'm met with Comcast and there's no reason at all for me to be sending out traffic with a AT&T IP address, and I'm sure Comcast is following a BCP 38. It's the smaller guys, but that's sort of an example of what we're talking about here. And once you find someone that's able to do that, and I think Mike, you said you were able to find some vendors for like $50 that allow you to do this. You're able to just, it's the ISP shooting themselves in the foot. It's going to take up their bandwidth, a smaller amount for a DNS attack. But this is such a basic thing that people need to be doing.
Very basics. And speaking of basics, there's also, as a tie-in to IDOR that was mentioned by Ricard in the last session, segment, we had a bug hunter. I'm mumbling right now. My speech is gone. Researcher found an IDOR in DOD, and it was essentially an account takeover. And one of the things that really just wanted to highlight here is that, yes, it's a good tie-in with the last segment, if I could get that phrasing out. But it's also one of the IDORs are one of the easier things to find as a human, but still a little bit harder to find in an automatic manner because it does require context, saying if I flip some URL parameters, and I see a response, am I supposed to see a response, or am I getting back a authentication or authorization challenge, or or is this just something that I'm walking through the catalog of widgets on a sales, on a merchant site? So I thought it was kind of interesting there. Real quick bug, and the details are not fully disclosed yet on the hacker one, but we have a link to it there. But speaking of web vulns, I think that does also lead us to something else you were highlighting, Matt, about web application threats and U.S. retailers.
Yeah, I thought this report was interesting. It was from Outpost 24, which is, a vulnerability scanner. But what was interesting is they looked at a bunch of retail sites and then kind of said, well, in the U.S., 8% of these are suspect, or only 4% of these are suspect in Europe. So that's an interesting kind of stat that the European websites are a little less suspect than U.S., making the U.S. retailers potentially more susceptible to attack. But then it also talks about how many were out of date systems and servers. And then the numbers were kind of staggering. I'm like, really? I mean, so we're in this environment where we talk about immutable infrastructure. We're talking about DevOps. We're talking about, pushing code often, but yet 22% in the US and 27% in the EU are still running old components in their applications, which makes them potentially vulnerable as well, since they're outdated pieces of software. So retail industry, get ready for Black Friday or Saturday or Sunday.
I thought it was Black November now.
Yeah, might as well be. I mean, it's the 10 days of Black Friday leading up to Black Friday.
It's film noir November.
Excuse.
But but one of the things too is just to your point, Matt, too, about a quarter of them have known components with known vulnerabilities. Finding those known vulnerabilities isn't even, you don't even need to pull in the DAS to find that. That's almost a single operation that comes essentially for free resource-wise if you're running through a GitHub, just one of the other source composition analysis tools. Those can find and fix those, or at least find them very quickly. So that's one of those things that is possibly pointing towards a weakness in a robust DevOps pipeline or robust DevOps maturity that has deployed such a, honestly, what should be a fundamental tool. And I think,
these are still monolithic-based applications that haven't moved to these environments, and so now they've got some potential, longer timelines to fix this stuff. But I'm going to tell you right now, retailers are not touching their websites right now. They won't, because it's such an important part of their revenue stream during the holidays that we've identified them, right? But my guess is these stay in this state through the end of the year, through the holidays, which means there's potentially attacks and breaches coming that are going to be successful.
Yeah, that's a great point, because the code trees right now can be, when there's a problem, anything that gets pushed out, that's very directly quantifiable into lost revenue. So set aside security for a second, but just a bug that causes an outage, causes an empty shopping cart, has direct money that can be tied to it. And John, I think you were going to add something too.
Well, I was just going to, spend a few seconds thinking about the frame of thought of these organizations. So either you don't know that you've got vulnerabilities. Let's case zero is you've done your job and you're good. So thumbs up to those guys. But for the rest, you don't know you have vulnerabilities, and you're going to try and get these fixed next week or so, or you're crossing your fingers really tight for the next 90 days. Good luck to the guys in the third category. Maybe try better next year. We've talked about all the sort of the pros and cons of when you can patch and all the things around this. But this is, as Matt was saying, this is your core business window, and you're entering it with your pants partially unbuckled. Good luck.
Good luck. And I think that gives us a chance to talk to a pair of articles here. One about testing in production. And this article very much is just written for a software testing perspective, a quality testing. It doesn't even have the word security in it, but it has a lot of implications for security if you can test in production, just as we were talking about last segment. And another article, Matt, that you highlighted too, steps to make DevOps possible.
Yeah, I thought the testing in production 101 was very interesting when we just had the last segment where, Rickard said, look, we can't test in we can't scan, we can't do security testing in production. Now you want to do QA testing in production? So this article is just interesting timing, because we were having this conversation about, organizations not wanting to do security testing in production. How are they ever going to get to this level?
Yeah, and I think one with testing in production, one of my things that I really like is that it talked about feature flags. And feature flags can be sort of call it a shadow security mechanism, in the sense that if you find a feature that has a flaw and you can't, let's say you don't have that WAF to virtually patch, or you don't have another mechanism to, or you're worried about rolling out changes, or you don't know how complex or how long it will take to have a fix, if you can feature flag to toggle a type of feature that has a vulnerability, that can suddenly become a pretty useful capability. So I'm not extolling that as a security mechanism necessarily, but it does have some potential for security benefits, depending on, of course, context.
Yeah, and so think about this, right? I'm going to relate this to the next article, which is the DevOps discussion, maybe I do have an IAST in place and I am doing some interactive capabilities. By knowing that I have that, I might be able to get away with aspects of doing this in production, right? Because I might already have some tools or capabilities in place to facilitate this. And as you turn on some flags in certain areas, you can start to roll this across your environment and do some testing along the way. But that means I understand what I have. And I think this is one of the big challenges. We were talking about asset inventory in the last segment, but asset inventory not of just your web applications, but think about all your capabilities in your development process and in your security testing process. What tools do I have? What's already there? Can I leverage that to do some of this stuff? Can I create some operational efficiencies both during development, test, and production, or not, right? And that's what brings in these 7 kind of rinse and repeat steps, because this is going to be one of those fine-tuning processes that happens for a while for most of these organizations.
Yeah, and those steps, the 2 that stood out to me, there was step 2 of this article says, use the 5 whys. Why are we doing this? And kind of just really poke at the problem and understand what's going on. The 5 whys are also a great approach for postmortems. What went wrong? Why did it go wrong? Things like that. And the other thing that stood out to me is number 6, which essentially says, ruthlessly eliminate all humans, or possibly all manual steps. But I would have phrased it slightly differently. But
that's the way Sean Malloy would have said it too. We're going to eliminate the humans.
Exactly, ruthlessly. So a great pair of articles there to think about. Let's get DevOps maturity, because that was one of the things too that you brought up in the prior segment. We don't just start with a bug bounty. We don't just start necessarily with one solution. We need to understand, why do we have problems, or do we even have a way to find software insecure dependencies in our code? And if not, what's the smartest way to use our budgeting process that Matt is unfortunately suffering through today, to find that efficiently? And that's where those whys can come in. A couple more whys, I think we can switch to some things that maybe are jumping towards the future of computing. And there's another article that John, you highlighted, that has actually a tie-in, if you will, to in principle to the idea of the SGX and the conclave, or the idea of secure computing or confidential computing, but basically saying, how can we have, or even can we have, a binary that can run on a system where a attacker can observe how it executes and keep that binary's internal capabilities, internal computations, possibly even its internal secrets, all remain secret?
Yeah, so we started by talking about Platypus. And actually, this one hit my radar this morning, another SGX-related issue. So, and I think that, Mike, you're going down the right path. Focus here isn't so much let's sort of nerd out about another sort of, microcontroller or microcode issue in a controller. But to just cover it really quickly, people have figured out that it's not just a software vulnerability. Let's see, we were talking about, I forget the previous named one, not Platypus, but Plunderbolt, I think was the one a few weeks ago. So previously we had not the one today. It was that
not the one
previous
today.
one?
Sorry. Yep.
So today we're talking about we were just talking last week about keeping track of these names. So today we're going to talk about VoltPillager, but there was a previous version of this which was software-based, where you could, basically spike the voltage on the CPU and see what's going on. Someone took that a little further, and I believe Intel patched that one back earlier this year. But now we're talking about actually, if I can get my hands on that CPU, can I, what can I do to get it SGX? Right, back to our core story here. And people figured out with about $30 worth of parts, and I think you probably do it for about 15. But you're able to really sort of, throw a few leads on your CPU, a few wires, and be able to sort of start spiking the voltage or undervolting it, and be able to get some little tasty little bits out of SGX. So that's the technical part. Whoops. The problem here is the use case around this. Intel, while they've taken a step back and said, well, we're not considering physical access to be a threat vector that we're trying to protect against with SGX. Previously, they've been quoted saying, as I said before, looking at, hey, let's look at Azure and their SGX-based instances, and same with Amazon. These things, even if they're a data center, you don't have to worry about data center employees being able to snatch your data, which I'm still personally not too worried about that use case there. It's, your little instance is one of, in a single Amazon data center, you're probably looking at what, 50,000 computers. So you're pretty safe. But the fundamental problem here is maybe it's your laptop or a desktop or something around. If someone's able to get physical access to that, even if you're doing something, what you think is best case in SGX, that's not as secure as you might think it could be.
Indeed. And I also wanted to add, I threw in just a brief article here about 2 bugs in Chrome. And it's not so much to say there are 2 more, these are unpatched vulns, or they're patched now, but these were at the moment 0 day. But the idea of what you were going after there near the end is that are you threat modeling for the right thing? Meaning, if you are a U.S. retailer with a web app, have you fixed all of your software dependencies, or right now are you still worried about, or are you now worried about SGX enclaves, or even old school rowhammer attacks in the AWS data centers where you're running your web application? Probably you should be worrying about those web app software components first and fix those dependencies. The other thing in just bringing up Chrome, we had, sadly, they were unnamed vulnerabilities in these 2 high for that. But one was, of course, right in the Chrome component for JavaScript code, nothing too surprising there. The other was in a use after free, but it was in our site isolation that we had just talked about back in episode 127. So even though we were extolling the benefits of site isolation within Chrome and how it had just been implemented in Firefox, all of these implementations still highlight problems, in this case very high rated problems that were being actively exploited. So this isn't to say that necessarily site isolation is bad or Chrome is bad. It's more of keeping things into perspective of, are you maintaining your population of browsers at a good patch level? And if not, that's a great reason to start using those 5 whys and figure out why is that and how to fix it.
Mm-hmm.
Well, you got the same issue with the Facebook story real quick on the link previews, right? I mean, again, it's down to implementation. And absolutely, the Facebook story was a callback to episode 128. We were talking about link previews. And in this case, it was pretty neat. The one thing that stood out to me that I just wanted to talk about real quick is that attackers were using Facebook's link preview basically to bypass block lists and rate limiting on applications. So rather than going directly to an application to enumerate it, scrape it, pull down the data, they were going through Messenger's link preview capability and using Facebook servers for that purpose. And then because Facebook is ostensibly a more trusted third party, and you don't necessarily want to rate limit all of your potential users who are sharing information on Messenger about the links that they're coming to visit, you wouldn't initially think to block them. So really just clever way of trying to bypass or abuse capabilities that in new and clever ways. Yeah, and we've talked about abuse with APIs and rate limiting and potentially DDoS abuse through those. I think it was Signal Sciences a few weeks back. I mean, now you're getting into some very interesting use cases and edge cases where you have this API, it's there for a reason, but how do you prevent someone abusing that API, and how do you differentiate good versus bad use of that API to make sure it doesn't cause issues for your application?
Indeed. And quick announcement for those of you interested in more API security. In the Security Weekly Unlocked, I'll be having a session about API security. So definitely check out Unlocked and register and sign up for free, because we'll be talking even more about this. And hopefully we'll also be coming up with some good naming conventions for those. So for example, those Chrome vulnerabilities that I mentioned, I'm going to go with the 80s sci-fi movie references, that those 2 CVEs need to be named something like Chrome Death Killer or Isolation Breach. So that's what I'm going to start lobbying the CERT for. Not sure if you
We need
guys have
posters to
different
go
names
along
you want
with
to go
these.
for. That would be great. Adding, once again, to our Security Weekly merch. Check that out in the upcoming weeks for posters for our Chrome Death Killer Isolation Breach, also known as Platypus and SAD DNS array of fine merchandise you can have on your hacking hoodie. And that's the most commercial I can get for the podcast this week. I think I'm about out of brain cells and the ability to speak. Any final comments or observations, Matt or John, you want to throw on to any of the vulns or the tools that we talked about this week?
Not me.
Gosh,
I'm brain dead too.
I'm still amped up on copy. Yeah, sorry. For people with headphones on, are like, stop. Capital One on, I believe, Friday put out a blog post saying that they're open sourcing more of their tools. For those who haven't been paying attention to those guys, there's there's one tool which I'm going to be looking at closely, which is doing statistics around system calls on Kubernetes systems. They've done one which is a sort of the critical stack UI, so they've open sourced that now. They've got a GRC type thing that's doing governance and cloud cost management. So some cool tools there for folks who want to not just look at the vulnerability side, but how can we make this stuff better, and how are other companies doing it, and how are they doing open source? So take a peek.
Take a peek. It's great to see tools, and we would love to hear some more feedback from you about other tools you would love us to hear us talk about, or the ways that we could be talking about the vulnerabilities as well as the tools to find and fix them, or even better, prevent them. But I do want to make sure before we move along, say thank you to Matt, thank you to John, and thank all of you for listening to us and hanging out with us in our Discord channel. Thanks once again, and we'll see you next week on Application Security Weekly.